Assalamu alaikum. Welcome to the final year project presentations. My name is Jan Mohammad Afiq Amin and my groupmate name is Hanna Sami. We are going to present our poster, which is an approach of classifying waste using transfer learning method. So, uh, let's start. In our final year project 1, we have discussed about waste management using machine learning and deep learning, where we find how to segregate waste using machine learning algorithm and also deep learning algorithm. So we have used mainly 3 machine learning algorithm and 1 deep learning algorithm, which is SVM, support vector machine, random forest, decision tree, and convolution neural network, where we have found that CNN has surpassed the accuracy, and it has given an accuracy of around 90%, where SVM is given an accuracy of 85%, and random forest and decision tree given an accuracy of little bit lower. So as our future work, we have discussed that we will work with the CNN part, and then we will come with a good accuracy in the CNN part. That's why we are using now we will using various transfer learning method for our FYP2, and then we will compare between the FYP1 and FYP2. So here is our project poster. As you can see, I am going to describe the first part of this project poster. So let's start. So, in the abstract part, in the waste management process, currently the main challenge of the waste is that the garbage space is flooded long before the beginning of the following cleaning process at clear spots. So, the using of convolutional neural network, we are proposing an artificial waste classification problem. And the main purpose of this mission is to compile and organize the dataset into various categories, which are metal, paper, glass, cardboard, and e-waste. So we can distinguish between certain transfer learning, which is also algorithms, and for our project. And so the transfer learning methods are exception, DenseNet 121, ResNet 50, MobileNet V2, and EfficientNet V7. So from our result, we have found that DenseNet 121 has given an accuracy of 93.3%, and MobileNet is given an accuracy of 93%. So DenseNet 121 as one-to-one transfer learning has come up with the best accuracy after creating the best model for each algorithm. So using hybrid parameter tuning, whereas other are marginally behind. So DenseNet 121 has given a best accuracy for our project. Let's talk about the introduction part. So waste separation or waste classification is only done by unskilled workers currently, so which is less effective, time consuming, and therefore entirely possible due to a great quantity of waste. So it's take a lot of time, and also it causes pollutions to the air. So if we implement a machine learning algorithm, we have seen in our FAB1 that machine learning algorithm is not given that much accuracy. So and classifications, for the classification, deep learning is quite good because CNN given good accuracy. So if we implement deep learning method for this project, we can get a good approach, we can get a good accuracy, we can get a good model. So what's the problem statement? So for the problem statement, we have found that the production of waste has risen significantly, no doubt on that. So if this waste is not managed properly, they have been create a bad impact on our atmosphere, because the sorting of the waste in order to optimize the quantity of recycled materials, this should have been achieved at the initial level and reduce the risk of being tainted by other items. So with the work unprofessional workers who are unreliable, time consuming, and not productive, it will cause various kinds of problems. So what will be the research question and hypothesis? The first research question that we are going to discuss, which is what are the best suitable deep learning models for classifying waste with maximum accuracy? For our case, it's DenseNet 121. My teammate will discuss this later. And what are the key attributes for determining the correct objects? For the project objective, we'll first explore the dataset, then visualize the datasets and finding the correct images, then develop a models and label the images accordingly, and also we'll analyze the accuracy on the basis of some performance measurement like accuracy, precision, recall, F1 score, and confusion matrix, and we'll get the most effective algorithm for these operations. So what's the significance? The main significance of our project is that it can solve various SDGs and United Nations Sustainable Goals, which is number 14 or number 15 and also number 3. Goal number 15 is endorsed by this research, since life on land can only be safe if waste is properly handled. So if we manage the waste properly, it can be handled. And also AI will help to classify the waste, and it can contribute to the SDG. So that will be the significance of the project. So in the picture, as you can see that the the rate of waste that is been included in the per year. So in 2016 it is around in 220 millions per year, million metric tons per year, but which is expecting it to be increased in 2040 by 450. So it's a great number, and maximum of the waste is reduced, or 30% of the waste is reduced and substitute is 70%, recycle can be recycle is 20%, and dispose can be 23%. So if we do not take a step on this waste management system, then it will create a great problem for us. So that's it for myself. My teammate will describe the later things. Thank you. Assalamu alaikum.
Assalamu alaikum. So here is our methodology and workflow flow of the project. So first of all, we have used the publicly available dataset from Gary Thang and Mindy Young TrashNet dataset, and later on for this FYP2 we have gathered more dataset on e-waste category using image scraping using Google API and Bing Image API. So later on we have pre-processed the data and eliminated the unnecessary data from the dataset, and then we have used the tool as Google Colab as the tool, and Python Jupyter Notebook. Google Colab provides free GPU. As our problem is regarding to the deep learning problem, it helped us a lot in terms of training our model with a free GPU. So in the main techniques we have used transfer learning models. So what is transfer learning model? Transfer learning model is a as you can see is a pre-built weights of state-of-the-art architectures. So ImageNet comes with an competition every year, and there you have to classify 1000 different image categories, and different teams from all around the world comes with their solution, and among them the best one gets selected and wins prizes. So these are some of the state of the art algorithms we have used in this case: exception ResNet 50, DenseNet 121, MobileNet V2, and EfficientNet B7. So we have tried out with 10 to 15 different transfer learning models, and among these we have eliminated the others and selected this in terms of the model size, accuracy, and the performance. So for the data split, we have used 80% data as the training data and 20% as the test data, and from the training data we have used 10% for the validation data. So let's talk about the performance measurement of our models. So we have used the criteria as accuracy, precision, recall, and F1 score. Here are the result analysis of our research. So as we can see in the accuracy, DenseNet 121 has been able to get the highest accuracy among other models, and the others most of them are performed more than 86% in terms of accuracy. Recall, precision, and F1 score, these criterias are also very helpful in determining the like quality of the model. So here we can see we have compared in with different transfer learning models, and we have shown the all the categories result. We can see the trash category is not performing very well. The reason is because as deep learning needs more and more data, in our trash category there wasn't much data available. That's why the model is performing low in this only this category, but on the other ones, as you can see, some of the models are getting like more than 97% accuracy. So that's from the result analysis. So let us see about the future works. So the future works would be finding more accurate models with best hyperparameters for deployment. So we have tried with different transfer learning models, and as the technology is getting very much developing very rapidly, later on more transfer learning models can be applied on the same data to see the more accurate results, and also some hybrid models can be tried, like Inception ResNet or something like that. If we combine or CNN SVM, we can do the hybrid models. So in that way we can try out to get more accurate models, deploying the models on mobile and web app. So in our project we have shown the demo of web application using Streamlit. We use Streamlit to predict the the images into different classes, and we have shown the with different models. So we can also in the future try to combine the models in the mobile devices for real time object detection can also be done, and also image segmentation for multiple images can also be done with the model, or with this image data set. So making a dashboard system and constructing a pipeline for the automatic model retraining. Suppose another new image data comes and the model is not classifying it properly, so we can build a reinforcement system, as you can say, like the model will automatically make a dashboard of incorrectly classified images, and it will retrain the model automatically, so that later on when the same image comes, it will classify it correctly. Assalamu alaikum. So here is our web application model. We have integrated our transfer learning models in this web application using the Streamlit library, which is an open source library. So here we have integrated the best 5 models from our transfer learning models here. So if we choose suppose efficient net, then if we browse, here is our testing folder. You can choose any of the folders. So if we choose something like trash from here, here we can see the image, the model classifies the image correctly as the trash. So let us try with another model, for instance mobile net v2. So if we choose any other folder like metal, any one of them, so here the model is predicting it is from metal category. Here is the confusion matrix of the model. If we try with another one, so maybe browse any other pictures, cardboard, let us see. So here the model is correctly classifying the image as a cardboard category. So basically that's all from us. Thank you very much for watching. Assalamu alaikum.